Bell should ring any minute now. Just waiting for a couple of last minute stragglers. Today we're doing half-angle identities. So if you have not written these down yet, please go ahead and write those down. Okay, let's go ahead and start talking about our identities. So the problems that we're looking at today will involve half-angle identities. So unlike your sums where you added two different identities together or your doubles where you doubled, these are going to be half the size. Now the formulas that we will predominantly be using are our sine formula, our cosine formula, and the first of the three tangent formulas. Now, technically, you can use any of these tangent formulas that you would like. The reason I'm picking the first one is if you look carefully, it's just sine over cosine, which is why I'm selecting it, just because that way it follows the same patterns as the other ones we have been doing. Now, a word of warning. When you were doing the double angle formulas, there were three options for cosine that would all give you the same answer. These do not appear to give you the same answer, but if you use algebraic manipulation, you can make them all the same. It just requires a lot more work. And I know that for us, we want to do as little as humanly possible on these. So those will be the ones that we're doing predominantly. Also, if you could go ahead and copy down this first problem. As you're doing that, I want to encourage everybody to not fall into the bad habits that you might have gotten when we did virtual remote last time. Many of you have worked super hard since we went back to face-to-face to get your grades where you want them to be. And I don't want you to let them backslide this week just because you're home. So I know that there's a strong pull to go to the bed and lay down, or start watching TikTok videos during class and all of those things. I'm going to ask you to try and resist as much as possible and try and stay present and in the moment with the class as much as you can, just so that you don't miss things. And you keep your grades where you want them to be. Okay, so let's talk about the half-angle problems. So the first two types of problems that we're going to be doing, so example A and example B, all have the same instructions. They say find the sine of theta divided by 2, cosine of theta divided by 2, and tangent of theta divided by 2. So you're being asked to take the given information and substitute it into the formulas. Now, what I want to point out to you, another reason that we use the three that we do, is that all three of them use cosine of theta. If you pick one of these two, you have to know sine and cosine. That's a little bit of extra work. Okay, so let's start with the first one. Now, what I want to point out to you is that we're finding the half angle, but we are given the full angle. So that is a full angle. And I'm using the angle symbol from geometry just so I don't have to write the word angle. That is a full angle. So notice that angle is not divided by 2. But do not let that concern you, because if you look at the formulas that are up above, notice it's sine of theta, not theta divided by 2. Or sorry, cosine of theta, not theta divided by 2. Cosine of theta, not theta divided by 2. Cosine of theta, not theta divided by 2. So when we go and we fill these formulas in, even though we're finding sine of theta divided by 2, we're actually going to be using the full angle. So when we fill this in, we're going to write 1 minus 4/7 divided by 2. Let me scoot it up just a little bit so it's a little further into the screen. Okay, so you can use your calculator to do these problems and put just the part I'm highlighting into the calculator. But I'm going to try and encourage you to use your brain. Why? It makes you faster at these, and it actually takes longer to write it in. So we're going to start with our numerator, and we're going to turn that 1 into 7/7. That way, these two fractions have the same denominator, and we can put them together. So I end up with 3/7 divided by 2. Now you're going to hear me say this over and over and over and over again today. When you divide a fraction by 2, you double the denominator and the numerator. Let me show you why. And I'm not going to keep writing it over and over again, but I just want you to see why. The reason that dividing a fraction by 2 makes the denominator twice as big is because you're really multiplying by the reciprocal of the denominator, which is 1/2, which turns that to 3/14, and that is your final answer. Now, you should expect that the problems that are in this particular section tend to have nasty looking answers. I will not ask you to rationalize. I do ask you to reduce your fractions. So if you have something obvious like 2/10, go ahead and turn that to a fifth. But that's your final answer. You are done with that problem. Let's go on to the next one. And then if you have some questions, I'm going to ask you, you can either put those questions in the chat or you can turn on your mic and ask them. So you're going to write plus or minus, then write a big radical. Don't skimp on your radical. You'll be sorry you did it. 1 plus 4/7 over 2. Now, just like last time, you can put this part in your calculator, but it's actually probably faster to just turn that 1 to 7/7. Now your fractions have the same denominator. So you got plus or minus 11/7 divided by 2. Now, just like last time, I'm going to say the same thing. If you divide a fraction by 2, double the denominator of the fraction, which means this is really 11/14, and you're done. That's it. That's all there is to it. You are finished. Okay, what kind of questions do you have about plugging into this formula? Simplifying this formula, dealing with those fractions, anything at all that's bothering you at this moment. Don't worry, we will do it again. So if you're not 100% sure, you feel like you have a question, but you're not totally sure if you have a question, maybe the second problem will spark that question. We can always come back. Okay, let's go to our third fill-in. Now, again, the reason I like this version of the formula, because remember there's 3 to choose from, is that it's sine over cosine. It's going to use what you've already done. So again, nice big radical, 1 minus 4/7, which we have already calculated, and 1 plus 4/7, which again, we have already calculated. So using what I know from up above, because remember, that's that 1 minus 4/7, that was 3/7. Using what we did up here, which was 1 plus 4/7, turned to 11/7. And I got 3/11, and I'm done. So let's talk patterns that appear on all the problems. For sine and cosine of the half angle, if you look under the fractions and you add 3/14 to 11/14, that sum is 1. That's going to happen all the time. If you look at your tangent and you look at these two fractions, 3/14 and 11/14, if you were to stack sine over cosine, you get tangent. That's going to happen all the time. So notice those patterns that will help you check your work. All right, any questions? All right, then I'm sliding to problem 2. If you're starting to zone out on me, stand up. Do a jumping jack. Get your mind moving again. I know it's hard. It's really hard. But I have confidence you can do this. Okay, so problem B is sine of theta equals 4/5. Okay, so in the last problem, we were given cosine, and the problems require, and I mean every single one of these, requires that you know the cosine of the full angle. I don't have the cosine of the full angle. So this is where I'm going to use Pythagorean identity to solve that problem. So I'm going to use Pythagorean identity. Don't forget, you got to square that 4/5. Out of sight, out of mind. We forget how to do these sometimes. So cosine of squared theta ends up being 9/25. Cosine is 3/5. Still doing okay? Any questions? All right, so now that we know cosine of that's a full angle right there. See, I'm using that angle symbol from geometry. Let's go take that cosine of the full angle and put it in the formulas. So let's start with sine of theta divided by 2. So I'm going to have 1 minus 3/5 over 2. I'm going to rewrite that 1 as 5/5. And just like you're going to hear me say a lot today, if you take a fraction and divide it by 2, you double its denominator. So that just becomes 1/5. Oh, went off the screen. There we go. Who has a question about your sine of theta divided by 2? Okay, then I'm moving on to the cosine. Remember, you can ask those questions either by turning on your mic or by putting something in the chat. All right, this time I've got 1 plus 3/5 divided by 2. And just like I did on the last problem, as soon as I write that down, I'm going to rewrite that 1 as 5/5. And now I have 8/5 divided by 2. And as you will hear me say over and over again today, if you divide a fraction by 2, which is 8/5 is a fraction divided by 2, you are going to double that denominator, making that 8/10, which turns into 4/5. And I would like to point out to you again that that sum is 1. Doing okay? Any questions? That sum is 1 right there. All right, then we're going to go to our last one, and that is tangent of theta divided by 2. And again, the reason that I picked this formula from all others isn't because this formula is the best one. It's because I've already done all the math. And all I'm doing is just plugging things in. Okay, step number 1, fill in your formula. Now, like I said, I'm not going to do any math here because I've already done it. 1 minus 3/5, that's right there, that's 2/5. 1 plus 3/5, that's right there, that's 8/5. And I'll point out to you that that denominator is the same as that denominator, which means they effectively cancel. So I end up with 1/4. Now that's your answer. You can stop there. I know that some of you right now are looking at that going, hey, isn't that a perfect square over a perfect square? If you want to simplify that, you can. But for half angles, I do not expect you to do that. You could stop there. Or if you happen to luckily see a perfect square over a perfect square, go ahead and simplify it. But I'm not going to ding you if you don't simplify that radical. All right, who has questions about how to do a problem where you're asked to do sine of theta divided by 2, cosine of theta divided by 2, tangent of theta divided by 2? Y'all doing okay? All right, then let's go to our second type of problem today. Now, this type of problem is a little different, okay? I want you to look at the directions for this. It says use the half angle formula to find the following. Notice it's not asking you to find sine of theta divided by 2 and cosine of theta divided by 2 and tangent of theta divided by 2. It's asking you to just do one thing. So when I'm doing these problems, I will only be working one of the three formulas, unlike the ones on the front. Also, notice that the ones on the front, they said cosine of the angle equals something. On the back side, what does that equal? We don't know. So these are going to be a little different. So we're going to write ourselves a note over here next to the directions that say start by multiplying the given angle by 2. Now, I'm going to explain what that means in just 1 second. I just want you to write it down. So unlike the front side where they gave us the full angle, so if you look at the front side, notice that's a full angle. See, it says cosine of theta. It doesn't say cosine of theta divided by 2. On these problems, you are going to assume, and I know assumptions are a bad thing, assume that that is the half angle. Okay, so we're assuming that's a half angle, which means if we want to do our formulas, and again, I'm going to put them back up one more time. These all require the full angle, cosine of the full angle, cosine of the full angle, cosine of the full angle. Well, this is a half angle, which is why for our starting step on these, we're always going to take our half angle times 2 so that we can find out what the full angle is. So this is just one of many things that are a little different about this type of problem versus the other. Now this one that's right here, that is theta, and it's a full angle. Questions? Or you're still waiting to see what's going to happen? I understand. You may want to wait and see what's going to happen and then ask a question. It makes perfect sense. Okay. So unlike the front side where we had to do 3 problems, we're only going to do 1. We're going to do whatever it tells us to do. So we're going to do sine only of 3 pi over 8. Okay, now on the front side, we knew what cosine of theta was equal to. On this side, we don't know. Like they don't have a little statement up here that says cosine of theta equals 5 over 6. They don't have that. So we're going to have to use our unit circle. So you put your theta in right there over 2. Now, if you need to find your unit circle, go find it right now. Don't wait. Go get one right now. If you're working on your computer with us right now, you can always Google unit circle on your phone, and one will pop up for you. Okay, so hopefully at this point, everybody's found a unit circle, either on your computer, your phone, on paper. And you're going to look up what cosine of 3 pi over 4 is. I found negative square root of 2 over 2. So at this point, I got some cleaning up to do. Again, if this were just me, you know, we weren't working together, I wasn't teaching how to do this, I would just put 2 pluses there and move on with my life. But since this is your first time doing it, let me fix those signs for you. Okay, now when we're on the front side, we had a nice rational number there, okay? It didn't say square root of anything, and we could put that in our calculator. If we put this in our calculator, we will end up with basically just number garbage coming out. So we really need to do this by hand. So I'm going to rewrite that 1 as 2 over 2, so those fractions have the same denominator. And then I'm going to clean it up. So I have 2 plus radical 2 over 2 divided by 2. Any questions? Now, before you think that you are never going to fix this, we got one step left. We're at the end now. Here is our final answer, plus or minus square root. Now, the same thing I'm going to say to you all day long. If you take that fraction and you divide it by 2, you double that denominator, so you end up with 2 plus square root of 2 over 4. And that is your final answer. Now, do all of these have such terrifyingly awful answers? No, but if you anticipate, like you should, that these are going to have wretched answers, if you get a nice answer, you can be pleasantly surprised. But expect these to be awful, just awful. I mean, look at that. That's 2 plus the square root of 2 divided by 4, all under another radical. So you got a radical with a radical. It's just, ugh. All right, how about questions? Anything at all that's puzzling about this? I'm going to do another one here in just a moment. And by the way, if we need to come back to example A after we do example B, you just got to let me know. Okay, so let's look at example B. Example B asks you to find the cosine of pi divided by 8. So this value, the one that I'm circling, that is a half angle. We need the full angle so we can put it in our formula. So let's go do that. So we're always going to start these problems by multiplying whatever we were given for an angle by 2. And then that pi over 4, that is a full angle. That's what has to go in our formula, okay? We don't have a choice about what we put in the formula. We have to put the full angle. Pi over 8 just won't work. Okay, last problem we did sine. This time we are only doing cosine. So we're going to do cosine of pi over 8. That's the half angle, equals plus or minus. Write yourself a nice big radical. Don't skimp on your radical. 1 plus, and when you go over here, after the word cosine, you're going to put in the full angle. Now you're going to go look on your unit circle, and you're going to find out what cosine of pi over 4 is. Again, don't skimp on that, okay? Give yourself a nice big fraction. so you can read what you're writing down. Okay, we're going to replace that 1 with a 2 over 2 so that the denominators will match on the two fractions. Nice big radical. 2 plus square root of 2 over 2 divided by 2. And as you've heard me say multiple times today, if you divide a fraction by 2, you're going to make that fraction denominator double. So our final answer is 2 plus square root of 2 over 4. That is a nasty little critter right there. All right, what kind of questions do you have? Anything at all? Don't worry, we're going to do one more, as has been the case with everything today. Sometimes 3 is special. All right, let's go to our final problem. It is tangent of 7 pi over 12. As we have done with all the problems before this, I'm going to start by finding the full angle. Done. Okay, we're going to do tangent of the half angle equals plus or minus, nice big radical here, 1 minus cosine of the full angle, 1 plus cosine of the full angle. I know that's a little scary. Don't worry, it's all going to work out, okay? Just got to be a little patient with yourself. It's all going to work out. Okay, so you're going to go to your unit circle and you're going to look on your unit circle and you're going to find out what that value equals. Did everybody find negative square root of 3 over 2? Again, if this were just me working this problem myself, I would just make that plus plus and a minus here. But because, you know, these are your notes, I want you to have the nicest ones possible. So this becomes 1 plus square root of 3 over 2. And the bottom becomes 1 minus square root of 3 over 2. Don't worry, it's all going to work. It's all going to work. It's going to be fine. It's going to be pretty. It's going to fall out real nicely. We've got 2 steps left. That's it, 2 steps. Okay, rewrite your ones as 2 over 2, so your denominators match. 2 over 2, okay? So that means my top fraction becomes 2 plus square root of 3 over 2, and my bottom fraction is 2 minus square root of 3 over 2. So I have a fraction over a fraction in a fraction. Now I'm going to highlight this. Notice that those match. And since they match, they effectively disappear. So that your final answer is plus or minus 2 plus radical 3 over 2 minus radical 3. Yeah, it's a radical with a couple of radicals underneath. And that is where you stop, my friends. All right, what kind of questions do you have? Anything about anything on the front or the back? And again, sorry if my voice was so soothing that you just passed out there. That really wasn't my intent. Okay, so stuff that came up in previous class periods, just so you have all the information. A couple of students said, so on the back side, I only have to work one problem. I don't have to work three. That is correct. On the front side, you do have to work three. You'll notice the directions are different, and this will be mirrored on your homework as well, that the ones on the front side, the directions say find 1, 2, 3. Like you have to find sine, cosine, and tangent. On the back side, it says use the half angle formula to find the following. Notice that's a singular, use it once, okay? So your directions up here say use the half angle formula, period. Like it doesn't say do it 3 times, it says do it once, okay? Other stuff. Let's talk about your quizzes. So if you made an A or a B on your quiz, so that's anywhere between an 80 and a 90, feel good about that, okay? Those quizzes for this unit, and it has nothing to do with the universal remote learning, it just has to do with this unit as a whole. Those quizzes are typically pretty rough for some students. And the reason for that is in most math classes, all you're asked to do is replicate what I'm doing. Like I don't ask you to do completely original thought. And on that quiz, you had to do stuff that you really hadn't seen before. I mean, yes, you'd seen parts of it, but it was very original thought because there's not one way to do it. So that can be very challenging. So if you found that you are really lost on that quiz and did super poorly, and yes, there are some people who bomb that quiz. Like I'm talking like 10, 20s, 30s kind of bomb that quiz. It happens every year. It doesn't have anything to do with this year. It's just that material. Let's talk about options. First option is you could retake that quiz with a different set of identity proofs to do. And you are certainly welcome to do that. Before you take it, I will ask to see your day 1, day 2, and day 3 homework, just so I can give you some feedback on it and make sure that you really understand the concepts before you attempt it again. Next, you can use your test grade to replace that grade. So let's say that last week you were just really struggling with it. It didn't click. But after we do a review tomorrow and the next day and the next day, everything clicks for you. You make a 96 on the test, I will take that 96 and replace that 36. Like just replace it, okay? Then the third option is if you're still struggling with it, you can do the note card project, and the note card project will completely replace any summative grade you tell me you want replaced, okay? So you do have some options on that. Does anyone have any questions? Okay, the last thing that I was asked about in first and second period is people ask me about finals. What I can tell you is I don't know. I know that Johns Creek is not doing finals this year. I do not know if that is an option here at Centennial. I would direct you to reach out, or your parents to reach out to Mr. Campbell about that, and he will be able to answer those questions since he is the big man in charge. All right, so he would be able to give more information about something that would have to be a school-wide policy. All right. So if you have no questions, let's talk real quickly about your homework. All right, so again, I do want to point out you do not have to print stuff. I know some of you are stuck at home, no printer, you're like, end of the world, am I doing the homework? No, just write the problem down. Don't be such drama queens about it. So the first problems that we have up here, there's 3 of them. This is just like what we did on the beginning of our notes. Those first 2 problems, you're asked to find sine of theta, cosine of theta, and tangent of theta. These are the ones where I give you the equivalent value for theta and you just plug it in, you simplify your fractions and all like that. Then there are 3 problems at the bottom, okay? These are like the ones that we did just then. Those are those half angle problems. You're going to do sine of pi over 3, cosine of pi over 2, tangent of 7 pi over 8. These are the ones where you start by multiplying whatever that angle is by 2. Okay, so notice how different the directions are. Hopefully that will give you a clue about what you're supposed to do. Any questions at all? All right, if you have no questions, you are welcome to head on off to your next class or lunch or whatever it is you have coming up next. I will wish you all a fantastic day. Bye. Bye, everyone. Yeah, my main camera's not working, so that's all I got there. So bye. If you find you have any questions, let me know. We can definitely figure stuff out for you. But keep it up. You're doing great. I hope you all have a great day.